Hi, this is Florent Busnu from Azimuth System. In this video, we'll talk about how we can test the drone into the lab. So today, as you may know, there is no fitting models that are defined for drones. However, there is still a lot of things we can do in the lab to test drone, and more precisely, sophisticated drones that can record video and stream it directly to the controller using a real-time video stream. So what can we exactly do in the lab? We can test propagation delay, for example. As you may know, today the controller and the drone can be very far one from each other, even a mile away. It can go to very high speed. So we are talking about something like maybe 30, 40 miles per hour. This is very, very high speed velocity for drones, and it has a huge impact on what the controller is receiving on the video side. And what we want is when we control a drone using the controller, it might be that the drone is so far that you can even not see it. So you really need a very high quality video on your controller in order to be able to control your drone. We'll also talk about path loss. Path loss can be easily simulated in the lab using a channel emulator, and propagation delay. And the last thing I would like to talk is the geometry of the drone. Indeed, as you can see, a drone has 4 parts, and on 2 of those, most of the time, we have 2 antennas. So the controller has 2 antennas on each side, and the drone has 2 antennas as well. So most of the time, those antennas are, one would be here, for example, and the other one would be here. And we are using spatial diversity to send the stream to the controller, and from the controller to the drone is the same technology. So to be more precise, we use Wi-Fi connection between the drone and the controller. It can be either 2.4 or 5.9 gigahertz. So actually, I should do it like that. So each antenna from the drone is sending signal to the controller. So this is N0, and this would be N1. And we use spatial diversity because what we want is to ensure that even if the drone is 1 mile away, we still get a strong enough signal on our controller in order to get a real streaming video. But there is some corner case that we have to study. Imagine that your drone is rotating on itself. At some point, the antenna 0 will be here now. So this would be antenna 0 at time t1. This one, antenna 0 at time t0. And this one, antenna 1, will get to antenna 0 location actually. So this will become antenna 1 at time t1. So the drone just rotated on itself. So imagine this happen. In this condition, this antenna 0 at t1 will be hidden by the drone itself. So you won't have the, as you get here you could see you had a line of sight signal between the controller and the drone, and you don't have it here anymore. So when the drone is rotating on itself between the time t0 and t1, what you will see is, if I take, this was here, so you got a power P0, then the drone starts rotating, still have a pretty strong power, and at some point it would get hidden by the drone itself. So the power this guy will receive from the controller will decrease. So, and when now the antenna 0 will go around and go back to its initial position, then you will still have this strong signal. So actually, if you imagine this is the power value, and this is the angle during the rotation. So actually, we have to deal with a situation where we have a drop of the signal in one antenna at a time. Because if now we take antenna 2, we just did it for antenna 0, this was antenna 0, and if now we do the same thing for antenna 1, we'll see that when this one is hidden is here, the other one is here, and still have the line of sight to the radio controller. So the power will still be strong enough. But then, when it will start rotating, go here, you'll have the same kind of drop, but 80 degrees further. Sorry, it's not really nice, but you understand the math. So, and this is something that we can actually do today, even without any fading model, with our channel emulator. So how can we simulate this kind of stuff? What we can do is, actually we can do two different things. We can just go on the field, take a drone, and just record some rotation of the drone using our Field-to-Lab technology. So we will get the log from the drone and from the controller, feed this into a CSV file, and record those data again. And this will be already a very good way to start to emulate this kind of condition and see how the drone performs. Now, if you do that, you will still take into consideration path loss, some propagation delay, but also the fading model, because on the field you will still have some reflection and it won't be like a pure Butler model, for example. So the other way to do that would be to go into an anechoic chamber. By going to an anechoic chamber, you could take your controller, your drone, and do this test for every degree. When you get all those very clear data, you can just use the same way as the Field-to-Lab, take those values, put it in a CSV file, and replace those values again and again. So, another thing that we can test when we talk about the geometry of the drone is the tilt angle. Imagine you have the horizontal plane with your remote controller on your horizontal plane, and now you have your drone. But your drone, so first position, your drone is on the horizontal plane. But then, if your drone starts going in this situation, where it creates a tilt angle. So this is a tilt angle with the horizontal plane. This also have an incidence on the power that your drone will receive, and hence the power that your controller will receive. And this is also a hot topic for drone manufacturer and something they really need to test. So the same way, this would be much more difficult to recreate on the field actually. The only way to do that would be to go again in the anechoic chamber and test the drone for different tilt angle. When they get those values, we can feed the channel emulator with a CSV file, getting all those power values. So those are the main topics that drone manufacturers are facing today, and you see that fading model can wait actually. There is already so many parameters that we have to take into consideration today that make the a channel emulator very performant to test drone in the lab. So all I wanted to show you in this video was that there is already a lot of stuff we can do with a fading channel emulator, even without talking about fading model itself. All those topics are real topics and will make a difference in the next generation of drones. Testing the drones only in the field is very complicated for drone manufacturers because of regulation that is very hard in almost all countries in the world for now, because of all the parameters that are influencing the drone itself, the interference. We didn't talk about the interference today, but this is something we could do even further. But just to show you that there's a lot of things to test and there's a lot of we can do for you. Thank you for watching.